Today I'm going to show you a quick prototype that we've developed in the last 5 days, which plugs together the protocol in the mechanisms paper with the Bacalhau compute node and IPFS, and is currently running on hard hat, but soon will also be running on IPC. So without further ado, we have here, what are we looking at? We have a hard hat node, which is running a private Ethereum blockchain that will be replaced with a high performance IPC subnet. Soon we have ngrok, which is just running so that this block explorer can access the Ethereum network running here. And then we have a watcher watching Bacalhau jobs that are submitted as my user on the bottom left. And then we have a bunch of different parts of the modicum system, which we're going to run one at a time. So the first one is a contract manager that connects to the Ethereum network and deploys contracts. And so you can see the single contract that is deployed here. There isn't much detail about it in the UI, but it is there. You can see it. Then we are going to run the solver. And the job of the solver is to match resource offers with job offers. Resource offers are effectively compute nodes, and job offers are clients that are requesting jobs to be done. Then we have a directory, which in the productionized version of this, if we build it, will be primarily solved by IPFS. The directory is just a place for both clients to submit their jobs to, including any input data, and also a place for compute nodes to write their output data to. And then we have a mediator, which is a semi-trusted third party, which we're going to do some work to replace and not require this semi-trusted mediator. But the mediator's job is to some of the time rerun some of the work. Then we have the resource provider itself, which is we've modified this resource provider to be backed by Bacalhau rather than backed by a local Docker instance. And then we have the job creator itself. And in this case, this is going to submit jobs. And so what we have here, this is the script for what the resource provider does. It just posts a job offer of 1, which means all of the resources on this machine. And then what the job creator does is it posts these jobs that you can see here. And so here, for example, we can see there's a job with a spec, which is to run this script inside this container image. So without further ado, let's ask the job creator to create the job. It's going to submit it to the contract. It's going to coordinate, and there we go. We saw the job submitted to Bacalhau. So now you can see this Hello World job, which we've just hard-coded for now, is running on the Bacalhau network, and the output from that is available on IPFS. It should be. There we go. There's the outputs. Sorry, I should just be looking at standard out because it just writes to standard out. And any moment now that will say hello, which is the same as the standard out that you can see here. There you go. Yep, you can see that this is hooked up to IPFS. And you can also see all of the blocks that were mined in the process of implementing that interaction that's defined by the modicum protocol. So what these transactions correspond to is, I can kind of summarize what the protocol does. The contract manager deploys the contract, the solver registers, the directory registers, the mediator registers, and the resource provider and job creators, they all register with the contract. Then the resource provider registers its job offer. The job creator registers the job request. The solver matches the job offer to the resource offer, and then we'll also randomly determine whether to rerun the job on the mediator runs the job, at least on the resource provider, and then will some of the time ask for that job to be mediated. So yes, the full details of the protocol are in the paper, of course, but this is just a quick demo showing that we've hooked everything up. And now that we've got this running end to end, I think this is a great place to start from in terms of refining the protocol as we go forwards. So thanks for watching.